Okay, so this is a quick video that I'm making just to remind and review with you about solving equations. So yesterday in class, we introduced a new method about solving equations called a cover-up method. And I really like that method. And so we're going to talk that through on this page too. We're going to show that here in problem 4 and problem 5. What I want to remind you of in problem 1, 2, and 3 is just kind of like, for lack of a better word, the regular way that we've solved equations, maybe that you've been taught in the past, and the way that we kind of introduced solving 1- and 2-step equations earlier this year at the beginning of the trimester. And so, yeah, that's how I'm going to review on 1, 2, and 3. And then on 4 and 5, I'll review solving by covering up. And then you'll have a practice sheet where you can practice these 2 strategies. And so that's what we'll do today. So let's start with problem number 1. And I'll zoom way in here. So we're going to work on number 1. And we see a 2 times x, and we see a plus 17, and that equals 35. So basically what we have to do here is get x by itself. So in order to get x by itself, we have to undo a plus 17 and a times by 2. To undo things, to get things by itself, you have to do the opposite. So the first thing that we're going to do here is we are going to subtract 17. And we have to subtract 17 from both sides. Just like our mobiles, when we do the same thing to both sides of our equals sign, and I can even put a line down it, when we do the same thing to both sides of the equal sign, it keeps the equation in balance. And that's what we're really after here. That's what we are trying to do. We're trying to keep it in balance and balance it all the way until we have x by itself. So when I do this, my 17s on the left side go away, and I am left with just 2x on the left side. And now that'll equal whatever 35 minus 17 was, and that's 18. So now I'm really close. I have 2x by itself. I need to get x by itself, and I have to understand that 2x means 2 times x. So again, I need to undo that. I need to do the opposite. So the opposite of times by 2 would be divide by 2. And so I have to divide both sides, again, by 2. And when I do that on the left, those 2 cancel, and it leaves me with just x. And then on the right is 18 divided by 2, which is 9. And that's my answer right here. X equals 9, because I have x by itself, and on the other side, I am left with just a single number. And so that's what we're trying to do. But it does get a little more complicated. Sometimes problems get a little bit bigger. And so in problem number 2, there's a little bit more going on here. We have a 2 on the outside of some parentheses, and so that means 2 times the stuff in the parentheses. And then the stuff in the parentheses has a 3 times x and a minus 5. So again, we need to solve for x here, and so we need to do the opposite of everything that's happening. So in order for us to do that, let's work with this 2. Right now, it's being times by what's inside the parenthesis. I could distribute that in there if I wanted to. I could times that by 2 and that by 2. I'm not going to do that method on this video. I'm going to remind myself that, again, this means 2 times this stuff. So if I just do the opposite of that to both sides, I can get rid of it. Now, remember, when I say both sides, I mean, hey, we have a left side of the equal sign and a right side. And on the left side, I'm being multiplied by 2. So the opposite of that would be divide both sides by 2. And when I do that, multiplying and dividing at the same time cancels those 2 out. And then it'll just leave me with the 3x minus 5 that's on top. And since that's the only thing there now, I can just drop the parentheses. I don't need to have that anymore. Now, that will equal 8 divided by 2, which is 4. And now we have a situation that just kind of looks like the problem up above. Numbers have changed a little bit, but we're going to work with this 3, which means times by 3, and this minus 5, which is a subtract 5, to try to get the x by itself. And again, we have to do the opposite of everything. So let's start by doing the opposite of minus 5, which would be let's add 5 to both sides. Minus 5 and plus 5 will go away, and that'll just leave us with 3x, and then that will equal 4 plus 5, which is 9. And then finally, we have 3x. Again, that is 3 times x, so we can undo that by dividing both sides by 3. Those 3's will cancel out, and we have x equals, and 9 divided by 3 is 3. So x equals 3. Awesome. Let's keep moving. And now, again, another tricky one. It's small, but there's a lot going on. We have a fraction with the x attached to that, and that equals 6. Now, remember, a fraction is really just kind of like a division problem. The top number is multiplying, and the bottom number is dividing. So for us to cancel that out, right, we have to do the opposite of those two things. So if we want to cancel out the bottom, since right now it's dividing by 4, I should multiply both sides by 4. Let's start with that. When I multiply both sides by 4, I'll have 4 times on the other side, and of course I have to do it to the right side. Again, left and right of the equal sign. And so on my left side here, I have a divide by 4, but now I have a red times by 4, and so those two things just cancel out. And that leaves me now with this, and that is simply just 3x. And then that will equal 6 times 4, which is 24. And then remember up here where I said, hey, the top number is what we're multiplying by. Well, I think now you can see it a little more clearly. We have 3 times x. And so that means we're multiplying by 3. So to do the opposite of that, we should divide both sides by 3. And our 3's will cancel, and that will leave us with x all by itself, and 24 divided by 3 is 8. And we've solved that one. So perfect. So those first 3 examples, those are just like performing algebra, undoing what's there by doing the opposite and working your way to getting your variable, in this case x, by itself. Now, for 4 and 5, I want to model the cover-up method. And it's going to be a little challenging digitally, but I'll do my best. We'll see what happens. So I'm going to do some covering up. I'm going to do some like covering up and then uncovering. And so just bear with me here a little bit. So the idea of covering up is this. We need to look at our equation on the left side. And we want to try to figure out, hey, what's the last thing that's happening here? So spoiler alert for you guys. The last thing happening here is we are adding 6. We originally thought of a number. That's what our x is. Then we subtracted 3. Then we multiplied it by 4. And finally, we added 6. So what we're going to do is we're going to cover up everything except for our last thing. And we want to treat what we've covered up as just like some number. And so we're thinking to ourselves here, hey, I have some number plus 6. And when I take some number and I add 6 to it, I need to get 18. And so what we are trying to do here is figure out, hey, what's that number? So I know that some number plus 6 gives me 18. Well, the only way that'll work is if that number is 12, because 12 plus 6 is 18. So I'm going to write 12 down. I'm going to put an equal sign. And so what has to equal 12? Well, now we're going to uncover this again. So when I take this stuff away, what was being covered? Well, all right, I'll put it back. What was being covered? The 4 times x minus 3. So that's the thing that needs to be 12. And now we just keep repeating this process. So now we're looking at this, and we don't care about what was up there anymore. We're only looking at what's in blue. And so now I got to think to myself, hey, what's the last thing they did here? They started with a number, which is x. They took away 3, and then they multiplied by 4. So multiply by 4 was the last thing they did. So what I need to now do is cover up everything except that. Oops, I missed. So I'm going to cover up the x minus 3 part. So now I'm thinking to myself, hey, what's happening here is I have 4 times some number. And when I do 4 times this number, it's got to equal 12. So I'm thinking to myself, okay, 4 times what number will equal 12? Well, 4 times 3 equals 12. So I'm going to put a 3 down here, and I'm going to write equals. And now we uncover that number again, right? So I'm going to take that away. And when I take all that away, I see that what was being covered was the x minus 3 part. And so I put it back in there. That's what has to equal 3. And so now I do it one more time, right? I think to myself, hey, what's the last thing here? Well, they thought of a number and then they subtracted 3. So minusing 3 is the last thing here. So I one more time can cover up everything except for that last piece of information. So again, I'm thinking to myself, hey, I have some number, and when I take that number and I subtract 3 from it, it has to equal 3. Okay, so what number, when I take away 3, will equal 3? Well, that would be 6, right? So I'm going to write equals 6, because if I have 6 and I do minus 3, I get 3. Well, now we uncover again, and we think to ourselves, hey, what was covered? And it turns out it was just the x. And so now we've got it. The answer here was x equals 6. And you could plug that back in and check your work, but that's exactly how it works. So now we'll go back to 5 here. All right, we'll do it again. So I have 90 divided by n plus 4, and when that happens, it equals 9. So I want to cover up some things again. I want to think to myself, hey, kind of like, what's the last thing going on here? Or another thing to think about is, hey, cover up, the stuff kind of around where the variable is. And so what's happening here is we're doing 90 divided by this thing on the bottom, and when I divide by that thing on the bottom, it has to equal 9. So what I'm going to do is cover up that thing on the bottom. And I'm going to think to myself again, hey, if I do 90 divided by some number, it has to equal 9. So I'm thinking to myself, okay, 90 divided by what is going to be 9? And I will find out that 90 divided by 10 is 9. So that some number must be 10. So I'm going to put equals 10. And then what exactly equals 10? Well, that's what I get when I uncover this. What I covered is what should equal 10. So it turns out n plus 4 should equal 10. And so now I'm thinking to myself again, hey, so if we're going to figure out what n is, I should cover up everything, the last thing, everything except for the last thing. And then when I do that, that number needs to equal 10. And so let's see what happened. I thought of a number and then I added 4 to it. So I should cover up just the n now. Because I need to think to myself, hey, I have some number here, and when I add 4 to it, I get 10. So what number plus 4 is going to give me 10? Well, that number would be 6, because 6 plus 4 is 10. So then I come back and I uncover again, and I write down, hey, what was I covering? Well, it was just the n. So I write the n down, and sure enough, hey, we've got n equals 6, and we're done. And so that's a quick review, and I know it wasn't really that quick, but that's a review of a couple different methods of solving equations. And so I'll kind of zoom out here. In 1, 2, and 3, we did just the algebra methods. We saw what was happening. We did the opposite to both sides all the way down until we had our x by itself. For 4 and 5, we did the cover-up method. And it's essentially the same thing, but it helps us just focus on different pieces of the equation at different times and just kind of think it through rather than having to write down all these minus this or plus that or divide by this. We just kind of think it through. And so I think that's a really powerful method. So now, thinking about what we just did here and what we just described, use this to help yourself as you practice through the rest of our practice worksheet for the day. All right? Make sure you get that fully done and make sure you turn it in. I will collect and look at that worksheet next week. So thank you very much, everybody. Have a great day.